Hey, welcome everybody. Good morning. Those of you who are coming in, we still have plenty of seats down front. They gave us the big room here, which is nice, but there's plenty of room down front if you want to move forward with that. So this is the talk on extending your pipeline with shared libraries, global functions, and external code. My name is Brent Laster, and we'll go ahead and jump into it. A little bit about me very quickly here. My day job is a senior manager in R&D at a place called SAS in Cary, North Carolina, which means I answer emails, I go to meetings all day. So for fun, I do some global training and speaking here and things like Git, Garrett, Gradle, Jenkins. I've written a few things, professional Git book, working on a Jenkins 2 book too, which some of you might be interested in. It's supposed to be out in spring of 2018. Do some Safari online training on Git and Jenkins. There's a LinkedIn contact for me and also a Twitter contact in there. The books I've got out there, the professional Git book on there if you need a reference for Git out there for advanced or starting out. You can, there's lots of labs in there. Seems like it gets some pretty good reviews. And there's the Jenkins 2 Up and Running book, which I am actively working on with O'Reilly. Should be out in spring of 2018, covering all the good stuff, declarative pipelines, the pipeline flow, shared libraries, Blue Ocean, all that. So look for that. Also do, as I mentioned, some training on Safari. You can find some classes out there if you're interested. Things like migrating your environments to Jenkins 2. I've got a class on that out there. If you follow me on Twitter, I'll announce on there when I'm doing classes for them. So you can get on those if you're interested. All right, so enough about that. Let's start in with talking about shared libraries. So our starting point today is with Jenkins pipelines. That is, we're not talking about the traditional free-form things, of course. We're talking about how do I incorporate shared library code into my pipelines. And as you may be aware, probably everybody's aware by now, there's two forms of Jenkins pipelines as code. There's what we call the scripted pipeline, which is essentially a groovy program with the Jenkins DSL included. That doesn't do it justice, but that's essentially kind of how it's easiest to think about it. Then there's also the declarative pipelines out there, which have the more formal structure out there, more formal error checking, and the different pieces that are more suited to things like Blue Ocean. Blue Ocean works best with declarative pipelines, those sorts of things. So we'll be talking about how to use shared pipelines or shared libraries in both of those kinds of things as we go through the course. Start off with what is a shared library. So we can say a shared library is essentially code or functions that you define within the specific structure that Jenkins understands. We'll talk about what that structure is in terms of the directory layout and such a little bit later on. And they're also stored in a source control system. They're stored, for example, in a Git repository out there. We have both internal and external ones. Jenkins itself has an internal Git repository. It's not talked about that much anymore, but it's there. And we'll mention it kind of for completeness and in case it does become useful to you. And these libraries are automatically downloaded by Jenkins and made available to your pipeline on import. So when you tell Jenkins to either implicitly import these things or you tell it to explicitly bring these things in, then when you start running your pipeline, Jenkins will grab that source code repository with your libraries and bring it in and make it available to your pipeline out there. We talked about the internal and external, we mentioned that. There's also different access levels, trusted versus untrusted. This is not necessarily required for you to use pipeline or libraries out there, but it's something you may run into. So I want to kind of give you an idea of how to deal with that. This is a case of if your library tries to call certain routines or certain functions that are not approved to call, how do we get around that? And then there's also the dimension of scopes. Jenkins 2 has a lot of different kinds of structures now. It's not just the traditional jobs, as we've been already hearing about. It's also things like the folder structure out there, where you could have a folder that actually has a namespace that groups jobs together. There's multi-branch pipelines, where Jenkins can detect Jenkins file existing in a branch in your source control repository and go out and create jobs for that for all the different branches. And then there's also even like GitHub organizations where Jenkins can create jobs for you automatically based on the projects in a GitHub grouping or organization out there. Those kinds of groupings can each have their own set of shared libraries that are not global to everything, but are only appropriate to those kinds of groupings out there. So why do we use shared libraries? Some of the obvious reasons here: centralizing functions, sharing common code, code reuse, masking complexity. One of the things about pipelines as code, as probably a lot of you know, is that you have your pipelines written, looks a lot like a Groovy program. You don't necessarily have to know Groovy to be able to code up a pipeline, but it looks that way, and it can be confusing sometimes to people who aren't as familiar with programming or Groovy, who are more familiar with putting things into the Jenkins web forms, for example. So you could take some of that complexity, some of that stuff you might normally put into the code, and actually put it into a shared library and kind of abstract out some of the complexity out there. It also allows you to write code in a different syntax or a different language out there if you need to do that. We'll look at some examples of how to, for example, pull in shell scripts and have them executed a little bit later on. So our scopes with the shared libraries in Jenkins, we talked about rattled off some of these a few minutes ago. So Jenkins 2 has many different types of items that can be created. The folders, the multi-branch pipelines, the GitHub organization items, and each of these can have shared libraries that are local to them or only usable by them. This allows you to have a more dedicated kind of type-oriented functions to be available to those types and only to those types. Now at the bottom of this slide, you'll see a graphic here to try to kind of encapsulate the different levels of trust and untrusted here and the different types of entities we have in Jenkins 2. So what we've got there is in the entire Jenkins environment, on that first green bar there is an internal Git repository that Jenkins maintains that you can use for shared libraries called Workflow Lives. That's internal, and anything in that is trusted. And what we mean by trusted is it's able to make these calls into the lower levels of Jenkins or make Ruby calls in there, API calls in there, and do that without getting stopped or flagged by Jenkins. Then there's the global shared library in there, which is external, meaning that instead of being in the repository that Jenkins maintains, it's in any kind of external repository, like a Git repository or something outside of Jenkins, and gets pulled in from there. If it's a global library, it is trusted as well. It can do anything out there, any of the calls that it needs to. And then for each of the different other types of entities we talked about, multi-branch pipelines, GitHub organizations, folders, those can have their own local shared libraries in there as well. Those are considered untrusted. And these types of libraries that are untrusted, they run in the Groovy sandbox, and if they try to make calls outside of things, then they get flagged. So it's worth taking just a moment to talk a little bit more about what this trusted versus untrusted libraries mean. We will get to some code samples with shared libraries and stuff in a little bit, but this is the kind of thing you can run into when you start using shared libraries, so I think it's important to kind of start explaining a little bit more about this. So we said they can be either two forms, trusted or untrusted. Trusted libraries are ones that can use any methods in Java, the Jenkins API, Jenkins plugin, the Groovy language, etc. If they're trusted, they can pretty much do anything. Now with that, of course, becomes some responsibility for making sure that the people who can update those global shared libraries, those trusted shared libraries, are only doing the right kind of things. Generally, this is not going to be trying to prevent, like malevolent intent out there, but accidental misuse. Should this library routine really be calling into this lower level function here? Is this a safe thing to do? So if you're having people that have access to the Git repository, for example, that contains a global shared library, you want to make sure that they are people that you trust to be able in there to be making lower level calls and doing things in there. Untrusted code is code that's restricted in what it can invoke and use. It's not allowed to call some of the same methods or use the internal objects in there. And the untrusted code runs in the Groovy sandbox. We'll talk about more about what the Groovy sandbox is in just a moment, but essentially the code is monitored in there and checked to see if it's on the safe list of routines or functions to call. If it's not, then it gets flagged and it has to have a formal approval in there. In general, in Jenkins, certain scripts or methods require approval, and this is kind of going outside of the scope of shared libraries, but it applies to shared libraries as well in there. If you have a script or a pipeline created by an administrator, then that's automatically approved. It can add to it's automatically can do anything it wants. It's like the trusted model there. If a non-admin, though, tries to save a script, then it does a check to see if actions or operations are approved out there. If you're wondering what it means to be an admin versus a non-admin, historically what that's meant is an admin has the overall run scripts permission. If you go into the Jenkins matrix there and you have the overall and run scripts permission, then you're considered an administrator. So an administrator can do any kind of script they want out there. However, if you are a non-administrator and you try to run stuff that shouldn't happen out there, you can see an example here on the page where it says, it's calling something that seems like pretty mundane, get previous successful build out there. But that is a call that has to be approved. So if you're not running in the Groovy sandbox, then it flags it and says, okay, you've got to have this method or this script approved. The way that works in Jenkins 2, or in the newer version of Jenkins, is it sends a request or puts a thing in the queue in this thing called in-process script approval. If you go into Manage Jenkins, you'll see a thing out there for in-process script approval, and that means that there is a method or a script that somebody is trying to run who is not an administrator, and an administrator has to go in then and actually say, it's okay to do this, you're approved to do this. So the Jenkins admin then goes into Manage Jenkins in-process script approval and clicks approved, and everything is happy. So this can happen with shared libraries as well. If you have a shared library that you've written, or you try to make a call that it shouldn't be in, that has to be approved, same sort of thing. It's going to fail. It's going to say you have to have this approved. Then the admin has to go in and actually approve it. It'll add it to the queue. Trying to run an unapproved script is going to fail, typically with a message that indicates that it needs approval in the console output there. I know it's a little bit hard to read on the screen. Then the other kind of approval thing is Groovy sandboxing. So the idea that an administrator has to approve every non-administrative script gets really painful and really hard to manage really quickly. So they implemented this idea of the Groovy sandbox. And essentially, the Groovy sandbox is just a whitelist of approved methods. They're not considered security risk or dangerous. So if you are running your script, you've got the same thing up there, the call to get previous successful build, and you run it in the Groovy sandbox already knows or already accepts that this is an okay method to call. So in that case, if I run it in the Groovy sandbox, then it goes ahead and passes, and it doesn't have to have an administrator that's approved it. If there's an unapproved method found, then we fall back to it gets added to the queue, and the administrator has to go in and actually approve it in there, again, via the Manage Jenkins in-process script approval. There's also another kind of permissions check that you may run into if you are an administrator, for example, out there that says there's kind of an option on the script approval. Approve assuming permissions check. This permits running as the actual user. So what that means is I'm going to go ahead and approve this method assuming that the user has the appropriate permissions in Jenkins. So it's saying this should be allowed to run assuming the user that's running it has the appropriate permissions in there. Okay, so that's a real quick overview of the trusted versus untrusted. The other thing is the internal versus external. So this has to do with where the SCM, or the source control management system containing the library code, is hosted. Internally, Jenkins has an internal Git repository that can be leveraged for things like storing internal libraries, testing purposes, maybe doing some code reviews, staging some changes in there too. Probably not used very widely. It was kind of a precursor to a lot of the shared library stuff, but it's still there. Might be useful to you at some point, so I have mentioned it in here. Any content in here is trusted for all the scripts. Internally, the repository has a specific name called workflowlives.git, and it can be used with Git either through SSH access or HTTP access, meaning you can clone it down and work with it through either one of those protocols. Very quickly, if you want to access this internal library via the SSH protocol, you need to do a couple of things just in the way of setup. You need to actually go into the internal or the global security, configure global security section under Manage Jenkins, and put in a port number to get a SSH server port number there. We use a high one to avoid a privileged port in there. And then in the user configuration, you add in your SSH public key there. If you know what SSH is, the public-private key, you add in your public key there. And then after that, you should be able to clone it down. You can just do the git clone command as shown there, and you can clone it down just like any Git repository. If you're working on it on the HTTP side, if you want to use that protocol, you can clone it with the HTTP protocol, and it should work. There is a potential thing I run into a couple times where you get this message about requested URL failed, no valid crumb was included. Generally that means something mundane like you've been logged out of Jenkins. Jenkins is timed out there, and so you have to log back in. You might possibly also have to disable the prevent cross-site forgery attacks. Not recommended, but I have seen that as a potential workaround for that problem as well. Once you clone it down, you just go into the workflow lives directory, because that's the name of it or whatever name you cloned it to, and it's empty by default, but you can create a branch in there just with the git checkout -b. That's a shortcut in Git for create a branch and check it out, switch to it. And then you can start working in it and put your library stuff in there or whatever other code you want in there, and you've got that own internal library. More commonly, what we're going to do is have external libraries, meaning we create our shared library code, we put it into an external repository, some source management repository that is stored outside of Jenkins, like a Git repository. And of course, one of the things we have to do anytime we're bringing something new into Jenkins typically is do some kind of global configuration. It's the same with bringing in these external shared libraries out there. So you need to provide a couple of pieces of information to point Jenkins to how to get this library, to how to refer to it. On the screen up here, hopefully you can see that not too uneasily, but you give a couple pieces of information. First, you need to have a name for the library. So you have your source code repository out in the source management system, but you want to have a name to refer to this by within your pipeline scripts. In this case, I'm calling it utilities out there. You want to have a version. If you have the load implicitly option used, then you can use the default version. Load implicitly here basically means automatically load this pipeline library for me whenever I start up a Jenkins job. So automatically bring in this library whenever I start up a job. If you have that checked, then it's going to use the default version. The version here basically can be something like a branch name. It can be a tag. You put on like a Git tag or a Git branch out there. Most commonly, that's what you would use. And you can also allow the default version to be overridden. So even though you tell it, hey, I want you to always bring in the version at master in there, you can, if this flag is checked, it tells you to be able to override this to say, get version 1.2, 1.3, whatever the case may be. And then final piece of information is a way to find or retrieve it in source control. So what you're doing is you're setting up this mapping of a name in Jenkins to the actual source code repository that has your shared library code. Two options for where you're dealing with source control. One is called the modern SCM in there, and the other is called the legacy SCM. Modern SCM just refers to a source control plugin that has been updated to basically have a new API to allow working with shared libraries. Most of the things these days are going to be already updated for that. For example, Git, Subversion, Mercurial, Team Foundation Server from Microsoft, Perforce, those all have modern SCMs. If, however, you were using a source management system that did not have a modern SCM updated plugin, you could use the legacy SCM here. And the main trick with this is just being sure that you supply a string out there, the library name and version, the specification, so it knows what to pull in. Okay, then moving on. So if we have libraries defined, this is console output, but the highlighted point kind of shows you how Jenkins brings these things in. So in this case, you can see at the very top there, it says loading library utilities at master. That was defined in our global configuration. And you can see under that, it says setting origin to home git repository shared libraries.git. That's where I had this stored in my local Git repository on this machine. Otherwise, you'd be referencing whatever SCM location you had out there. On down there in the highlighted yellow piece, you can see where we're loading in the library workflow lives at master. That's the internal Git library if you were using that. That automatically gets loaded if there is content there. Jenkins is going to bring it in and make it available to you. When you're actually then loading libraries into your script, so you've created the library out in source control, you've set up the global configuration to give it a name, a location to pull it from, then there are a couple of different options for bringing it into your pipeline job out there. If you have content in workflow lives in that internal Git repository out there, then it automatically gets located into it. More commonly, though, if you're bringing in a shared library from an external SCM out there, then you would use, you have the load implicit flag set, then it's going to automatically bring it in. It loaded each time you start up. There's no annotation or no command to bring it in needed. However, if you're explicitly loading in there, if you want to restrict your pipeline to load in certain libraries, you don't want to have it loaded in for each job out there, then you use an annotation, a Java annotation. It looks like this, @library, then the live name. Now this is for the scripted pipeline model. For declarative, we'll talk about that in just a moment, but there are differences in how you bring things in for scripted versus declarative. For your scripted pipelines, though, you do the @library, then the live name. You can also put a version string after that, the live name at a particular version, bring that in. And this essentially prepares the class path as the class path of the script into your, for your pipeline to use. And then you can also optionally specify imports, meaning you can import methods, classes, variables out of that library as well. And if you have an annotation, though, and you don't have an import under it, then you have to specify an underscore. Okay, so real quickly, what that's talking about, if I'm just saying bring in everything from that shared library out there, I'm not trying to import specific pieces, then that annotation, since it's an annotation, it still has to have something to reference. So in that case, one of the tricks is you have to put like an underscore after that @library invocation, so the annotation basically has a placeholder. That's what that means. If you use an import statement in there, then the import statement is what gets annotated, and so that flows. Declarative syntax, though, has its own library section. It used to be able to do imports, but that's not supported any longer. And we'll look at an example of that a little bit later on. I'll show you what it looks like in declarative. And then as of Jenkins, the 2.7 stuff, there is a shared Groovy libraries plugin that adds a library step, an actual step you can just use anywhere in your script there to pick up stuff. And it actually will show you, we'll talk more about that in a moment. But actually it's just a library step to bring in your shared library directly at that point. Here's some examples of code loading in libraries. On the top left there, that's a simple bring in this library named mylib, and the scripted syntax there. Notice the underscore there is a placeholder again for the annotation because we don't have a specific import. Then in the next one down, we have, we're loading up version 2.0 of a library. That's an example of overriding the version if you want to bring in a particular version. Version, again, could be something like a branch name, a tag, that sort of thing. Then we get into an example there, a third one, @library, mylib, your live @master, just bringing in multiple libraries, importing specific methods there if you needed to, annotation with import in there. So for the one above, that fourth one down, you may be wondering why there's not an @library sign there. If you had an implicit load of the library, it would just bring it in, and you wouldn't have to worry about saying @library. Then on the right-hand side, this is an example of the declarative syntax, declarative pipelines. They have a libraries section in there, and you can use a live statement to load in your library that way. And as I said, as of 2.7, there's a new library step. You can put this pretty much anywhere in your script. You can just load in a library there, library my shared live, again with the same @version. One of the neat things, though, about this library step in that third example there under the 2.7 part, notice that it says @$live version. So with the library step, you can actually use an interpolated value or a variable to actually say which version of something you bring in. So if you needed to bring in a particular version based on some condition, you could actually use that. And you can also use that library there to bring in some static class methods. I'm going to save talking about that till we get a little bit further in here to make that make sense. Here's a quick sample library routine, just something I wrote. Basically, it's just to invoke a Gradle build with timestamps out there. So timestamps is a Jenkins pipeline DSL step. Tells Jenkins to just put timestamps on the console output there. The other part this does on the bottom there, the sh command is a shell step, so it's running a Linux shell out there. And then the tool command is just a tool step. Just says go and get the value of that tool from the global tool settings. In this case, go out and look out and see where my Gradle installations, where I have Gradle 3.2, go and grab that value and substitute it in here. So the shared library structure. So this is the structure that Jenkins is looking for or expects when you are actually working with creating these libraries. The first thing you see in there, the second thing I guess, is the source directory. This is expected to basically have, we'll talk more about that in a moment, but it's added to the class path when the pipeline is executed. This is more on the traditional Java Groovy structure out there for classes and methods, those sorts of things. Then there's a vars directory. They say it's for global variables. Vars is kind of going to be your utility for everything. You can pretty much put stuff in vars and have it work in declarative, scripted, all that sort of stuff. It's actually a little easier to use than other things. It can also have a corresponding text file with documentation, and we'll look more at that in a minute. The resources directory can have non-Groovy resources, basically data files. You have a JSON file or other kind of data file out there you want to pull in. So talk a little bit more about the source area. This is intended to be set up with Groovy files or in the standard Java directory structure, such as source, org, foo, whatever the file name might be. Gets added to the class path when the pipelines are executed. You can use any kind of valid Groovy code. Generally invokes some kind of pipeline processing. And there's several different options I'll show you here in a moment for how to implement the calls within the library and how to invoke them from the script. So lots of different ways to do some of these things. Here's one example of some code in the source directory out there. This, you can see the name of the file up there. It's called buildutils.groovy. It's in org demo build utils groovy out there. And then we actually invoke it and bring it in. So it's stored in the library, loaded implicitly. This can be loaded in a pipeline out there. That actually should be org demo source, I guess, or source org demo. Invoked in a pipeline via that little command and gray down at the bottom. Notice I define a value. Again, this is a scripted pipeline where you can define values. If this was declarative, you wouldn't be able to do it this way. I can define my utils equals a new instance of this, org demo build utils, and then I can just say my utils and call the method that I've got in there directly and pass some commands to it. Source example number 2, I could also create an enclosing class. If you want to do things like create a superclass out of it, it kind of makes that easier. You can pass in a constructor here. If you're familiar with Java, programming passing a constructor, you can pass in then things like the environment or the steps object. So from your script there, if you look at on the lower left side there of the screen, you'll see that we're calling it down there. We import org demo build utils2. We have the @library utilities to bring that in. Then we say build utils.timegradle build clean and build out there. And so you can actually then pass in, the constructor above that, a few lines up. Def build tools equals new build utils2 environment steps. Line 4 in the printout there. That's the constructor where we're passing in the environment and steps object from the script so that then our library routine has that. And you can see then in the build utils2 groovy up there on the upper right, you can see the environment and steps things get passed into the constructor, and then I can reference those within my library routine. So from the script, I'm passing in kind of the global environment object, the global steps object, and then I can call those within my library routine. So again, just different ways to kind of slice and dice things. Example number 3 here, I can also create a static method and pass in a pointer to the script object. This already has access to everything. Notice that this is a static one here, static timegradle build in there. Notice there that what we're doing is we're using the script.sh, meaning our script object that we passed in from our calling pipeline, then the shell step out of that, and then the timestamp step out of that. So similar sort of thing, just make sure if you use this form, you import it static. Notice the @library utilities import static there on the first line. Then we go into the vars area. Vars is defined as global variables, which you might tend to not think of necessarily as pipelines or of libraries or functions out there, but it's really kind of, like I said, the Swiss Army knife. You can put everything in there and it pretty much works. It's an area for hosting scripts that define variables you want to access in the pipeline. Scripts are instantiated singletons. The name of the function that you define, the base name, should be a valid Groovy identifier. And one of the cool things about using vars is you can also have a .text file with the same name, And when you use that in Jenkins, once it's been loaded, you'll have documentation built into Jenkins about that. I'll show you what I mean in just a moment. Here's an example one of using the var area. You can define a set of methods in a file. So we have in the vars directory, timecommand.groovy, we have the set command, get command, just different items in there, different methods. Notice that these are in the command and command out are not fields. These are objects created on demand. We can see an example there of using it in a script. I didn't show the actual loading of the library. It could be the library is loaded implicitly in there. I didn't show that part of it. But you can see we just say times command, the name of the file out there, then the various method in there that we want to use, and we can load it up. And on the right-hand side, you can actually see example output. It doesn't do anything very exciting. It just runs a command and sticks some timestamps on there as it's running. The automatic documentation I was mentioning. So if you are creating something in vars and you create a file name with the .text out there with the same name, then when Jenkins actually loads your stuff at least once, you'll be able to go into the global variables area and see the documentation. So if you're not familiar with this, if you go into the global variables information, the way I usually get to it, if you go into the pipeline syntax, hopefully everybody's seen the snippet generator. If not, you should check that out. It's basically kind of a wizard that guides you through creating the steps in a pipeline. But there's a pipeline syntax link on your jobs. You go in there, and at the very bottom, that little red circled area there, there's a little thing that says basically, hey, not everything is, a step. Some things are global variables. Click here to learn more. So if I look at the global variable things in there, that's stuff that is defined in the vars area from the shared libraries for one part of it. And so if I create this timecommand.text in my vars area out there, that text file, once I actually go in and load it up, then if I go into that global variables area in Jenkins, I'll be able to see the text file in there loaded as documentation. You can use markup, HTML, those sorts of things in there. So it's a cool way if you're doing shared libraries and you're using the vars area to create documentation along with that might be useful to the rest of your organization. Another quick example here, you can also use the call structure to create a function more like a DSL step in there. So in this one, I have, again, just a file, timecommand2 under the vars area, but notice I'm using a call format there and passing in options from there. And using a pipeline script, you just call the name of the file and then pass it in the values there. You can also do something they call passing a closure with the vars area. So you could take a defined method, you can define a method to take a closure and do some operation with it, which might be useful if you're trying to do things on a node. So for example, here's one where we use the call syntax again, but notice that within that, we're passing a closure, set of commands there. We have a node that we define, maybe it's a Linux node versus a Windows node or something to do something on a particular one. And we're actually running the commands on there that we pass in from the closure. You can invoke that from a script by saying the name of the command and then pass in a set of commands that you want to run within that. So that could be useful if you need to actually run some operation on a particular node out there and you want to just pass in a set of commands in there. And finally here, I think the last example we have on this is a DSL call with named parameters. This is a little bit different formatting, but you can actually create use a map within your library routine, that settings equals square brackets colon. If you're not familiar with that, that's a groovy map. And you can actually then pass in, use the values to pass in the mapping. So you pass the body into the library routine, you have a map in there, and then you can use that map, the settings, and the things you pass in from there. So the idea here is that when I invoke this from my pipeline script, I can actually use named parameters. That's kind of the bottom line with this. Makes it useful in certain cases. If you're trying, for example, to simplify it for people about, versus the ordering the parameters, those kinds of things, using the name parameter syntax can be a little bit nicer way to do it for them. And notice in the script up there, we call this the CMD and log file path. In our library routine, our map is called settings, and we reference in settings.command and settings.log file path to be able to use that within the library routine. The last directory we'll talk about of that section is resources. Files in this directory could be non-groovy. This is kind of like your data place. This is where you can load up things from a data file path you need them in your pipeline. There's a special step called the library resource step. You can load it in as a string out there. For example, there's a command in the middle there, def data file equals library resource, and points to the place out there where you can get the data file from. It can also be used to load up any resource needed in a script. Requires caution. I say that because you could do something like I've got there. You could say my external script equals library resource, some shell command out there, and then go off and execute the shell command. So you have to be a little careful, but it can be useful in certain situations to kind of separate out non-pipeline code. Typically it's meant more though to bring in data files, but I was just showing you an example there of how you can use it to do other things. Third-party libraries. You can also bring in third-party libraries to use in your code. This uses the @grab, the grab annotation out there, provided through the grape dependency manager. You may not be familiar with that, but it's built into Groovy. This is a way you can bring in things like from Maven Central. You can see in the example code down there on the right-hand side of the slide, the time command 5 Groovy. I'm pulling in the Apache Commons out there stopwatch function, just for something along the same time theme there, and I'm using that then in my library routine to time how long something took. Okay. I'm using that inside the library routine, then in my script side over there on the invocation, I can just call it the same way, but this gives you an example of how you can use some of the library routines in there. You can also load code directly in there. Similar to shared libraries, but not loaded from source control. There was one thing I wanted to go back to. Let me back up here just real quick. See if I can get back here. All right, I'll come back to it later. Let's go back here to loading code directly. Sorry about that. You can, similar to shared libraries, but not loaded from source control, you can have a function out there with the call syntax, for example. The main thing, if you're doing this, is going to have to do a return this function or return this command. This is necessary to make sure it has the correct scope. So if you were using this in a pipeline, there's a load command you can actually use to load your file in. And in this case, I'm defining it as myproc, loading it in, and then just calling myproc out there. But if you do this, again, you need to return this so it gives the correct scope when it returns. All right, quickly, let's talk about declarative pipelines and library directives in there. So if declarative syntax has the libraries directive, that's shown in sort of the part highlighted there in yellow. This is an example in a declarative pipeline with the structure that it has. It has this library section, a separate section, and it has a live then step in there it can be used to bring it in. It must be callable in declarative syntax. What that means is essentially you've got to make sure that it fits the declarative syntax model to be able to use it and load it. It's not a define some variable and then use that variable to call the library routine. Usually works better to use global variables to avoid having to try to use something from the class path. So what that means, it's usually going to work better to use something from do it in the vars area versus having it in the source path out there. From CloudBees, and this is something I got when I asked about this, they said unless you need to create one class with a bunch of static methods, it's easier to usually use global variables in the vars directory instead of classes in the source directory. In 2.7, there is a library step with pipeline shared Groovy libraries, or with the plugin for shared Groovy libraries. There's no annotation or section needed, so you can essentially just say, here's a scripted syntax library, and load in your library, and then run the command. It's a very simple syntax there. If you were doing declarative pipeline, it looks the same, essentially. So that's a nice feature of it. For a source area, if you wanted, so this is assuming again that you have stuff in the vars area, the global variables area out there in your shared pipeline library as opposed to the source structure. If you wanted to call something in the source structure, you have to fully qualify the name of the static method. So you'd have to actually go out there and use a longer syntax in there. You see highlighted at the bottom where I'm doing library utilities, org demo, build utils, time gradle build. It's sort of, you have to be very specific about it, because by the time you call the library step, it isn't put into the class path like it would be if you were using the annotation at the start of the script out there. Remember again, this is also one where you can use a computed value for the version of your library, name at a certain computed value out there if you wanted to do that. And then we can also load code from an external SCM, an external source controlled system. This requires a plugin called the Remote Loader plugin, which provides a file loader DSL. So you could actually invoke stuff. For example, here I've got something out on my GitHub site, one of my GitHub repositories, and I'm actually defining something there using the file loader from Git. There are different methods. There's one like from Subversion, I think, from Git, and those kinds of things out there, and telling it where to go. There's documentation there with the file loader method in there. It tells you more about it. You may be able to see in that gray area there, there's the from Git, from Subversion, and so on. And then you can just load it once you invoke it, kind of the same way as you've been doing before. Now, I will say that as I was writing the chapter in the book on this, and there's a couple of guys from CloudBees who are reviewing things for me, they said this is written prior to shared libraries. It's kind of a precursor to shared libraries, and it's not guaranteed to be maintained. So, kind of use this understanding that it may not always, it may not be updated, or it may not be fixed down the line in there, but it's available to you at least now. Finally, we're finishing up here, we're going to talk about replay for libraries. If you haven't used the replay functionality before, or haven't tried it, it's one of the cool new features of the pipeline with Jenkins stuff. So it's actually a way to go in and say, once I have a run of a job, I can go in, and if it fails, for example, I can pick that particular run, say replay, and what Jenkins will do for me is it will bring up a window there, a little window when I've got there, that says, here's your code. You can go in and modify it, and you can try to replay it. Basically means you can make changes in the code version that was present for that run, go off and try to run it and see if that fixes the problem. Then you can go back and actually modify your actual pipeline code. So the actual pipeline code doesn't get changed in that case, but it gives you a little window next to that run to be able to go in and modify the code and try things out. Well, the same thing can happen for untrusted libraries. They don't allow you to change things for trusted libraries, but if you do a replay and your code is pulling in some untrusted libraries, then it will actually bring up a replay window, an editor window in there for you to actually go in and modify the code in the library if you need to and try that out. Okay. The only other thing I guess I need to mention was there was a slide back there, but when you're implementing some of the shared library cases there, where you're implementing classes and stuff, sometimes you have to implement them as serializable. It was on one of the slides, and I'm trying to go back to it, but some cases you need to say that your class implements serializable. The reason for that is because of the thing you heard talked about it probably at the keynote this morning. One of the features of Jenkins 2 pipelines is surviving restarts. In order to survive restarts, the things have to be serializable, so anything you implement in that sense at the class level out there has to be serializable as well. And sometimes you won't be allowed to use objects that are not serializable. There are ways to get around that, but we won't go into all that right now. All right, so that's it. I think we're finishing up just about on time. Hopefully get you guys out here for lunch. I will stick around for any questions or be available. You can contact me here. Again, look for the book, early 2018. Thank you all for attending, and hope it was useful to you. Thanks.